What scientific fact is very often misinterpreted? Story 1. The chances go up by 80% factoid. If you're at risk 1% for, say, lung cancer, and your risk for lung cancer increases by 80%, you do not have an 81% chance now. Your risk is now 1.8%. And it's probably not the biggest deal, but it's a little important for stuff like understanding fertility and genetics. I've seen this confuse people a lot with radiation exposure. The limits in place are set at a level that has very minor increases to the chance of cancer and other issues. They don't mean if you go over the limit, you are going to get cancer. Radiation still shouldn't be messed with, but most people don't realize just how much background radiation they get just from things they eat, what they wear, and going outside. Go to the doctor and let them do their diagnostics tests. It's a very small dose that is much more likely to improve your life rather than make it worse. Story 2. Schrodinger's cat is a thought experiment that demonstrates why it's ridiculous to try and extrapolate quantum physics to any scale larger than particles. It was not intended to actually represent superposition. This one gets an eye twitch from me every time for how ironic it is, since Schrodinger only brought it up in the first place as an example of how people are misinterpreting quantum mechanics. It's not possible for a cat to be alive and dead at the same time, and nothing about quantum mechanics suggests that it is. The wave function representing the decay of the radioactive material collapses when it is measured by the detector. Story 3. Not a fact per se, but the way headlines and articles frame scientific findings. Scientists proved XYZ. No, they didn't. Researchers may have discovered evidence through observation, experiments, or other methods, but that's not proof. It's evidence, and it is completely subject to being challenged when examined alongside contradicting evidence. This is how rapidly advancing fields get a bad rap among the populace. Scientists keep flip-flopping on issue XYZ. They keep proving one thing and saying another a month later. They're all quacks and don't know what they're doing. Story 4. A lot of people think that just being in space is enough to make you weightless, as in, get far enough away from the Earth's surface, and you start floating instead of falling. Reality: astronauts are always falling, all the time, except that they also have enough horizontal velocity that the Earth's surface curves away from them as they fall, such that they can never land. Weightlessness is an illusion based on the fact that their spaceship is falling and curving around them at the same velocity. If it were possible to build a skyscraper tall enough to reach the space station's orbit, you could take an elevator to the top floor and stand there, weighing almost as much as you do back on the ground. Story 5. For evolution, the concept of our common ancestor with the apes. That misunderstanding is why we continually get the gem of, if we evolved from monkeys, why are there still monkeys? For the education of anyone who doesn't know and doesn't want to ask, this is how it works. Our closest ape species is the chimpanzee, with the split about 7 million years ago. What that means is that the last time we were the same species was 7 million years ago. The ape we both came from doesn't exist anymore. It's kind of like finding someone with the same last name as you. It turns out that even though you were born in Canada, and they were born in New Zealand, both you have grandparents originally from Cork, Ireland. So you trace back the great-grandparents and keep going back. Eventually, you find out you have the same great-great-great-great-great-grandfather. When we look at chimpanzees, we have roughly 500 twin greats in there before we have the same grandparent. Story 6. The Dunning-Kruger effect. It's the effect that people who are not so competent at a skill tend to overestimate their own performance more often than competent people. Redditors love to cite this effect, but they often present it as if the incompetent people perceive their scores to be higher than the competent people do, which isn't the case. They are just more likely than competent people to overestimate their own performance, which leads to a problem many statisticians actually have with it. It also happens when the data are randomly generated. If you score a 5 out of 100 on a test, and people ask you how well you think you did, the probability that you overestimate yourself is a lot higher than if you scored 95 out of 100. So the effect may just be a matter of how statistics works rather than how people work. But that doesn't stop people from citing the Dunning-Kruger effect as a slightly more sophisticated way to call someone stupid. After all, this is a prime example of Dunning-Kruger. Sounds a lot more intellectual than "you are stupid." Story 7. the concept of the heat death of the universe. A lot of people seem to think it's this single, relatively brief event where everything gets roasted to oblivion, but that's pretty much the exact opposite of what it really is. The theory is that due to entropy, the energy of the universe is very gradually dissipating, and matter is very gradually coming apart. In quadrillions of years, it will reach a point where it'll just be an even distribution of elementary particles throughout the entire universe. No more planets or stars or anything, just an extremely fine mist. In other words, it's not that heat will cause the death of the universe, but rather that heat itself will die. Much like with global warming, the scientists really should have picked a less ambiguous term for it. The terms are technically true, but practically a bit misleading. Now we've got the term climate change, which is a lot better, but I don't know of any alternative for heat death. Story 8. Confusing the terms theory and hypothesis. Pop culture is to blame. Any movie involving science always features some scientist saying, I have a theory. What is really meant is they have an unproven idea, which we call a hypothesis. To us scientists, theories come in two flavors. The first flavor are theories that are considered 99.99% objectively true because they have been rigorously tested and experimentally validated again and again and again by multiple labs independently of each other. Examples include evolution, the Big Bang, plate tectonics, germ theory, gene theory, quantum theory, and general and special relativity. Those last three are the most successful theories in all of science and human history. They have never once failed an experimental test of their mathematical predictions, though we have not yet tested all those mathematical predictions due to the limits of current human technology, and frankly, human cognition. The second flavor is mathematical theories. These are common in theoretical physics. These are not theories like evolution or relativity because they have yet to be validated experimentally. Theories like M theory and string theory fall in this category. Where the public gets confused is understanding what we mean by a mathematical theory. To the public, they can mistake these theories for just lofty ideas, but these theories are rooted in rigorous mathematics. This is not like the math you do in a math class. This kind of math must adhere to what we currently understand about our universe. For example, if you're working with math and physics, then that math has to obey certain things like the fact that time exists, or constants like the speed of light, or laws like the conservation of mass and energy. If while working on a physics theory, your math deletes the time variable, then you know you have to go back to the drawing board because we know that time exists. This is why a mathematical theory in physics is considered extremely strong evidence that we are on the right track toward answers. The next step, then, is to look at the mathematical predictions in that math and test them through experiment. This is how things become a full-blown theory in science. Story 9, studies show. I can show studies for anything, literally. Studies show breathing oxygen results in death. Yeah, because 100% of people who have ever breathed oxygen have died. Or because breathing 100% oxygen will end you. You can put any title on any research. It's important to read into their experiments and methods, especially these days as most research has to have a grabby fear-instilled title just like media headlines to get funding. Eric Weinstein does a great job of explaining this on his recent podcast on JRA. Even in college, professors explain you gotta find a way to stretch out your research grants. So even if your research was a waste, you should end it with something attention-grabbing to continue funding for the next phase. Although presence of XYZ in a home doesn't appear to show an increase in all-cause mortality, it does correlate to increased rates of family members who transition genders, further analysis required. Not technically a lie because there was one case of trans compared to the placebo group. And wow, it's a current social topic that will definitely get attention and funding. Story 10. You use 10% of your brain. False, you use your entire brain under normal circumstances. A long time ago, they began studying the brain, realized how complex it is, and stated we only understand 10% of the brain. Everyone misinterpreted it as that's what we use. Seems like it sometimes, eh? Some more recent science was a new strong telescope capable of detecting the equivalent of streetlights thousands of miles into space. We did not find streetlights. They were trying to help us understand how powerful this new equipment is. Kind of the same thing as above. The famous double slit experiment has nothing to do with molecules knowing you're looking at them. They move differently when the lights are on because light is photons and tiny molecules pushed around by the light. This I understand less, but I'm confident molecules don't give a crap if you're watching them. Story 11. Well, since I have been banned on the physics subs, this may apply to the question asked here. I think some confuse consciousness with the observer. The observer is matter. Matter is wrapped energy no matter what form it takes. Space is that same energy being unwrapped. The endless field of energy is space, the local matter bubble, is what we exist in. As it passes through that energy, it also unwraps, returning to the source. Some call this expansion. The entire process is circular. So, a perpetual energy system, our psychology is the biological self awareness we call consciousness, which may not exist outside our own local framework of nature's own biological evolutionary processes. As we are made up of matter, which is energy, but energy is always in transitions of change, wrapping and unwrapping, and our consciousness is but a biological byproduct of that process. What is real is the energy itself, and energy takes on many different forms, and all of them are transitional. Story 12. How time is relative, and how it slows down when you approach the speed of light. Yeah, I get it mathematically. I know c needs to be constant and cannot be exceeded, but I do not understand how you can physically change the time term. I have taken 3 university physics courses and watched Interstellar, LOL, but still cannot wrap my head around relativity and time dilation. I guess it is too far beyond the scope of my intuition and natural expectations for me to comprehend. Story 13. That living things are just made up of many smaller things and parts. My body is the product of trillions of cells, which are the product of countless atoms, which are the product of even smaller things like quarks and neutrinos. It's mind-boggling that I exist because a bunch of particles decide to get together and form larger things. Life is all about perspective. Well, give yourself some credit. When those smaller pieces come together, their interaction becomes less involuntary and more about triggering connections, speaking on the brain level, not on the atomic level. You're a big mess of interactions that don't want to stop forever, but do stop at times. But that's not what makes you you. What makes you you is the alteration of those interactions and situations that are similar but not the same to what you have tuned your brain to. I had some beers. Story 14. How can our consciousness be spread across an entire brain rather than one single point? It's amazing that we are decentralized in that manner. I was just getting a headache over this the other night. We know that everything that defines your, for lack of a better term, stream of consciousness is in your brain, and that if you swapped your entire brain above the spinal cord with someone else's, then you would be experiencing everything in their body, and vice versa. There was an experiment done in Salnesh by Robert J. White that technically achieved this with a monkey. However, let's hypothetically say we had a method that could swap out different portions of the brain that somehow created perfect connections with the rest of the brain without any complication, as if the swapped portion was always a part of your brain. For example, if we swap out your visual cortex with that of someone else's, then while there might be a noticeable difference, you would still have your ability to see the world around you. Let's set up an experiment in which I and some other person are swapping out different portions of our brain. Eventually, my entire brain will be in the other person's body's head, and their entire brain will be in my body's head. Every time a portion gets swapped out, we wake up and lift our arm in front of us, then get put back under. After which portion of my brain getting swapped with theirs, would I lift my arm up in front of me and suddenly find that I'm now controlling their body? Practically speaking, it could be achieved by swapping out all the bits that make up our memory, which would mean that I would lift up my body's arm, but think that I was originally the other person, and that it would appear as though I had swapped bodies with the other person. However, it would still be my stream of consciousness, and I'm wanting to know at what point my and their streams of consciousness swap. Story 15. Entropy. I guess a good analogy is that your room will tend to get messy unless you put in some effort to clean it. But the whole concept is still difficult to fathom. Entropy can be described as a disorder. Nature tends toward disorder. More particularly, things tend toward the lowest available energy state. For example, an egg falls off a table and shatters, spilling all over the floor. Normal, right? That's an increase in disorder or entropy. It's a movement toward the lowest available energy state. The egg has less potential energy because it fell off the table, landing closer to the ground. The impact broke the shell into pieces, which then themselves fell closer to the ground. The liquid spilled out all over the place. Now, you'll never see that egg jump back into its shell, heal the shell, and then jump back onto the table. Why? Because that would take an addition of energy to do so. Every step of the way, the objects that are free to move are moving toward the least available energy state. In order to reverse that, and thereby decrease the entropy, you'd need to add extra energy into the system to allow the egg white to go back to its higher energy state of being in the shell, and allow the shell to go back to its higher energy state of being on the table. Or put another way, water runs downhill because it's going from a higher energy state to a lower energy state. Reversing entropy would be like moving water back up the hill again. You need to put in at least as much energy as it lost going down the hill to get it back up there again. Story 16. I understand how evolution works, well, at least on a basic level. I'm not a biologist. But sometimes it's hard to comprehend how it can lead to something like eye spots. Those seem so deliberate, or animals that have evolved to look like other poisonous species. You start to wonder, how do their genes know what another species looks like? Not to talk about the inner workings of a cell and how it interacts with the rest of the organism. I do understand that there's been billions of years of trial and error with evolutionary pressures guiding the process, but some of it still seems quite insane. Story 17. I'm a biologist as well, OP, and I have to say, I quite like this question. Recently, I read a book called Life on the Edge, The Coming of Age of Quantum Biology. In it, the authors, John Joe McFadden and Jim Al-Khalil, argue that all of life is predicated delicately by the invisible quantum underpinnings, which collectively define the thermodynamic and electrostatic properties which govern and guide life's evolution. They gave some awesome examples like photosynthesis, light harvesting complexes, non-random quantum walks, which deliver excitons to the reaction centers of photosystems non-randomly via quantum superposition effects, and also copying errors leading to DNA mutations occurring in the unlikely event that a proton involved in purine or pyrimidine nucleotide base pairing quantum tunnels across the hydrogen bond gap that separates the two molecules during DNA replication, leading to the possibility of complementary base pairing and the rise of mutations within organisms, ultimately driving the evolution of all of life on Earth. My favorite aspect of the book, however, was the notion that life could only have taken root some 2.7 to 3.5 billion years ago with a helping hand from quantum mechanics. Learning about the monstrously improbable odds faced by an abiotic molecule as it begins its journey from simple organic compounds to enormously complex, yet, compared to modern life, elementary to the point of obscurity, self-replicators, really puts into perspective the extraordinary miracle that is life. That organic chemists spend their entire lives understanding and emulating an incomprehensibly small fraction of the collective journey of life's origins is a testament to the dazzling, spectacular improbability that life could really ever exist. I don't think I could ever put into words just how astounded I am at the accidental beauty of it all, but I suppose my answer to your question is life. Life just amazes me, man. Story 18. Why, if gravity is constantly pulling, something can orbit forever around while being pulled, and not just eventually be pulled down to Earth. That's pretty easy to explain. If something is in orbit, it is traveling around the Earth or whatever is being orbited at a certain speed. The direction of its speed is forward as it goes around in a circle. Gravity is always pulling it down towards the Earth, which means there must be something pulling up or moving it away from the Earth the same amount, so that gravity's force gets canceled out. What is canceling out gravity? The object's forward motion. If you drive in a circle, you need to turn, but the object isn't turning it in a circle. The circle shape comes from gravity pulling it towards the center. If you are anywhere on the edge of a circle and go forward without turning, you will start traveling in a straight line away from the center of the circle, perpendicular to the edge of the circle. This movement away from the center of the circle is such that the object stays the same distance from the Earth. Also note that the object never slows down, because the forward speed is always perpendicular or right angled to the force of gravity. So gravity is never slowing it. So that's why it could theoretically continue forever. For this to work, the math needs to work. The math involved is the force of gravity, mass of Earth, mass of satellite, distance between them, and speed of satellite. If something is going too fast or far away, it won't orbit, it will just fly by. If something is going too slow or close, it might just fall down to Earth. If it is going slightly too fast or slightly too far away, the gravity might be able to pull it into orbital speed or distance. Also, it's important to understand that the satellite needs to get its forward speed from somewhere. Without that speed, it would just drop to Earth. So, when we release satellites into orbit, we don't just go to space and let them go. We make sure they are already heading in a direction. Story 19. This is not what OP meant, but for me, it's what are the limits of what constitutes observation from a scientific standpoint? I can't really break this question down as much as I'd like, at work and on mobile. But I feel that failing to answer this question is what leads to scientists making claims about things that are simply beyond the scope of modern science. No one ever really considered the structure of the scientific method, but it's the single most important part of every experiment. Story 20. How something other than water can have 0 calories. If your body can't burn it for energy, the nutrition label will say it has 0 calories. For example, your body can't digest cellulose at all. Therefore, it has 0 calories to give to your body. If you were to swallow a coin, don't do that. You would also not be able to use that as a source of energy, so it also wouldn't have any calories. In reality, though, a lot of it has to do with labeling requirements. If a serving size has less than a certain small number of calories, 5, I think, per serving size, it can be labeled as 0. Story 21. Consciousness. On an atomic level, there are just atoms in me, non-living. On the cellular, there's cells. They do stuff. They operate together and make the machine that is my body work. But then, in the brain, in all the universe, since the dawn of time, there are these configurations of atoms, of cells that produce a perplexing property, a window into the universe. I mean, a window, literally. All of the atoms in you, and me, and your dog, and Pluto, and Andromeda, they're all atoms of the same universe. So when atoms get into fancy configurations, the universe is able to observe itself through quadrillions of little portholes on its skein, conscious beings being born and living within it. Hydrogen is a colorless, odorless gas that, given long enough, begins to